Hi, everyone. Hello, and welcome to DPLA's member webinar series. This is Samantha Gibson. I work on communications at DPLA. Today's webinar will be an update on our recent technology projects presented by Director of Technology, Michael Delabita, and Interim Network Manager, Gretchen Gagan. So first of all, a couple of pieces of housekeeping. Can everyone see the slides and hear me okay? And if so, please just type a quick hi, hello into the Q&A feature. Excellent. Okay, so seeing lots of highs, thank you very much. I think you'll find that you are all muted, but please do use this Q&A feature to post questions throughout the session, and we'll do our best to answer at the end or certainly offline if we don't have time today. The session is being recorded, and we'll make that available for reference and for anyone who wasn't able to attend. So with that, I'm going to hand it over to Michael to get us started.
Hi, can everybody hear me? I believe I unmuted myself. Okay, sounds good. All right, thanks everybody for coming today and giving us a chance to tell you about some of the things we've been working on at DPLA. We have a really quick, just mastering the controls here. For those of you playing a conference called Bingo at home, you just ticked a box. So here's our agenda for today. We're going to talk about our new website and lists and grid view, which are some features that we've added to the site since launch. We're going to talk about DPLA Local, which is something we're offering to our network members. We're going to talk about the analytics dashboards we recently built and released. Gretchen's going to do a bit of a deep dive on Ingestion 3. And then I'm going to come back and talk about our new data architecture, mass indexing, our new API that we're working on, and some new search features we'll be working on. So throughout all this, I'm going to do my best to make sure that I'm using terms that everybody understands, but I probably will end up forgetting or not realizing something. So we're going to have a question period right at the end. So if you want to save your questions until then, or if you mention something in chat and it catches my eye, I'll probably try to go back and explain something a little bit better. But I'm going to do my best. Okay. So first off, we launched a website this year, and I don't think we've had a chance to talk about this from a technical perspective yet. We obviously had a webinar. Our previous webinar was sort of going over the features of the new website, but there's some under the cover stuff to talk about as well. We worked with Postlight, a digital agency in New York, on a new design for the site, but we added our own refinements and enhancements during the implementation process. The new site is written in JavaScript and built on Next.js, which is a framework built on top of Facebook's React framework for building interactive web applications. This stack allows for a responsive experience and quick content rendering for browsers that support JavaScript, and it also offers a statically rendered fallback to ensure accessibility, which is obviously a very important thing to address. In terms of things that we built in here, we built a new search and discovery interface on top of our API. Previously, I believe some portions of our search and discovery interface did not use our API, so we cleaned that up architecturally. We have new interfaces for our curated content using APIs built into our CMS installs for these rather than theming them. So what that means is previously, when we wanted to make a change to our layout or our design, we had to re-implement it in WordPress, some of our custom software for search and discovery, into Omeka for exhibitions, and into primary source sets CMS. So really, we had to implement it 4 times. And then when we wanted to launch it, we launched 4 different things. And that was really cumbersome. It was error prone because this was literally new code each time. So you can make a mistake 4 different ways. And it was a lot of work to get things launched. So now what we have is we have a single front-end web application that speaks to the APIs for each of those CMSs. And that does a number of things. It makes changes really easy because we only have to implement and launch them once. And it reduces a lot of our attack surface in terms of security because we're not putting things like Omeka and WordPress out on the web and maintaining them. We're just maintaining this one user-facing open to the web interface. So that really helps for security as well. Another thing we launched during this rollout was our Pro site. This is a way of streamlining our user-facing product and also speeding access to our resources targeted towards our network and wider professional community. It's modeled after the same concept as Europeana's Pro site, if you're familiar with that, but we really took a page from their notebook there. Under the hood, this is actually the same software as our main site, but that's oriented towards end users. So literally the same code base, really nothing changes when we deploy this, but at runtime, when this thing launches, it uses some switches known as feature flags to disable portions of that site, enable other portions of the code at deploy time, which speaks for the flexibility of the code base. Essentially, we just kind of have two sites in one mingled together, and we're able to switch on and switch off parts of it when we deploy it. That leads us to how we're getting the content into the front end and enabling our staff to edit and publish it. For our blog, we're using WordPress REST API, which is a fairly new feature built into WordPress that essentially makes REST APIs on top of WordPress. So what that means is, we have a standalone WordPress instance where we go and edit things, and our front end is pulling from that API to present that information. So, if you actually went to the WordPress site, which you can actually, I think you can actually see the URL on this, you would see kind of like just a JSON feed. You wouldn't really see any content, but on our front end, it's pulling stuff from that WordPress instance and displaying it in our template and our stack. So in WordPress, we're using some custom Forbes plugins to allow us to use WordPress as the CMS while presenting the content using our modern Next React stack. And instead of hosting WordPress ourselves, we're using WP Engine to host it. And the reason for that primarily is security. 25% or so of the internet's websites are WordPress. The security vulnerabilities are well known. There's bots out there looking for them, and we'd rather focus on our product than kind of making WordPress work right. So when we pay WP Engine, they roll out upgrades, they test to make sure they worked okay. We don't have to really think about that. So that's really kind of a benefit for us being able to focus on our product rather than sort of like the minutia of some of the hosting that we rather not worry about. Okay, in terms of hosting infrastructure, we're making use of a number of AWS products, AWS meaning Amazon Web Services. The first is Elastic Beanstalk, which is an AWS feature that does a bunch of the orchestration around website hosting for you. It automates the deployment of load balancers, scaling groups, and domain names so we don't have to worry about it. So that means that if a server goes wonky in the middle of the night, or we get a lot of traffic and need to scale up to more servers, Elastic Beanstalk is handling this for us mostly automatically. I say mostly because there was one particular strange behavior that happened where it was really hard to realize that the problem was one of the servers needed to be replaced. And so Elastic Beanstalk didn't do any better than we did, but we did get around to figuring that out. So that was pretty easy. And then eventually all I had to do was right click and kill the server off, and it magically made a new one for us and everything was fine again. So another thing we're using is called CloudFront, which is Amazon's content delivery network, which we put in front of our site to push as much of the content to a server closest to the user. So if you imagine that in data centers across the country and the world, there are all these servers waiting to host some portion of our site and cache it for us. CloudFront is our way of getting to them. Finally, we're using something called Web Application Firewall, which is another Amazon feature that helps us stave off attacks from bad actors on the web. It knows how to filter common attacks based on the pattern of traffic it sees. So, things that are in the URL or in the query parameters, you can recognize as, basically bots trying to hack our site, and it'll filter them off. Also, we've deployed a configuration that automatically bans IPs from a few common block lists available on the web. So that means there's some people that are just giving us bad traffic. They're known bad actors on the web. That has reduced the load on our servers considerably and increased our uptime. It actually did reduce the number of outages we were seeing, and now we're pretty smooth. Another important consideration, and the last thing I'm going to talk about in terms of the website, is ease of deployments. Generally speaking, we want to be able to push out updates easily and not make launching something new a project in and of itself. So we built a deployment tooling that allows us to push out updates to any of these sites with a button press using Apache Jenkins, which is a continuous integration server. There's more than one way to do this. This is just what we landed on. But the outcome is essentially you push a button, you come back in a few minutes, and the deployment's out. We don't really, issue commands or, do anything really complicated. The site's in Git, we press a button, and pretty much automatically 5 minutes later, we have the site deployed. So that's been really helpful. Okay, so I'm gonna quickly talk about a couple of features that we added to the site post-launch that are sort of interface enhancements. The first one is lists, which you might have seen us blogging about recently or tweeting about. Oh, I'm sorry. I was going to talk about grid view first. The first one is grid view. And essentially what this is a way of looking at the items from your search results visually. It kind of strips away some of the metadata and the links, but it lets you get through a lot of items pretty quickly. You can see here that there are checkboxes on each items, which is part of the list implementation I'll get to on the next slide. But the idea here is that sometimes you want to be able to browse visually and see a lot of things side by side, and this gets you there. So you can see on the upper right-hand corner, there's a layout selection, and that's how you switch from list view or ordinary view to grid view. And otherwise it's basically the same search. It's just letting you see the thumbnails more clearly and move aside the metadata if that's the view you want. We default to the ordinary view, but we make this available for people who are looking for things that are visually what they're looking for, not necessarily just the metadata. And here's an example of a list I built in the new list feature. It's from my favorite search, which is food. It's how I test whether or not the site's up. Lists are another feature we've added. Right now, the implementation saves the list entirely client-side in something called local storage, which is something built into the browser APIs that are merging with HTML5. That means that the data is only available in the browser you're using to build this list. It gets around some of the privacy and legal compliance concerns that we might run into when we're saving stuff and maintaining profiles for people on the web. But we'll likely build server-side storage into the new API, which I'll talk about later. But in the meantime, lists basically just give you an opportunity to save some of your favorite items, or maybe you're doing some research and you need to track some things or come back to them later. They'll all be saved in your browser, and you can label them, and you can actually download them as a spreadsheet, so it's pretty useful. Okay, next I'm going to talk about DPLA local. DPLA local is what we call white boxable, in the sense that it takes our search and discovery interface, and for a hub that doesn't have their own web presence or doesn't want to run their own, or they would rather work with us to host theirs, it gives them a way of like branding and theming it for them and narrowing the collection involved down to their set. So we're working closely with a group of people from the hubs to better define what this is and what it should do. But essentially, you can see here that this is sort of a workup of what it would look like for Recollection Wisconsin. There's the opportunity to customize some stuff on this front page. And then if I flip over to the search and discovery interface, it's essentially, this is much smaller search results. It's narrowed down to right now what's administratively at Wisconsin's hub. And you can see that the colors across the top and the search button and the create a list from these items buttons have all changed to a theme that matches their colorway. We have the Recollection Wisconsin logo in the upper left. Okay, next up, I'm going to talk about the analytics dashboard. So the analytics dashboard is essentially another take on providing analytics data to our hubs and our network. We have been mailing out reports and giving people access to Google Analytics to see some of this data, but we thought we could do a better job of making a more focused interface and adding some like stuff that's not in Google Analytics to the mix by creating this dashboard. You can see here that in the lower right-hand corner, we've added some metrics around metadata completeness. It's sort of like field coverage. The definitions for those terms have come out of a working group that Gretchen has been working on and with. So that's sort of like, it gives you kind of an overview of the quality or the completeness of the field coverage in the set for a particular hub. You can also see here that we're showing some metrics about API usage in the DPLA API, which have not been kind of surfaced before. And then we're showing kind of more like specific web view stuff over here on the left where it says website use. We also have added some timelines, some time series views to this that give people the ability to look at changes in usage over time. You can see in the upper right hand corner it says start and end. You are allowed to change the month or months that are being looked at for this particular view. Also, you can see here that there's sort of like an overall view of the types of search terms that come in both through our website and our API to give people an idea of what kind of information is being looked for. Okay, so I am going to hand control over to Gretchen now, and she's going to do that deep dive about ingestion 3.
Yes, so I'm going to talk about the saga of trying to get metadata into DPLA. So, oh, right, Michael, next slide. I just clicked down like I had controls. So, DPLA, so metadata harvest and aggregation at DPLA basically follows this kind of high level, these high level steps. We gather the partner's metadata. We do that in a variety of different ways. We create new DPLA metadata application profile records from those original records. And as part of that process, we modify some of the values to create consistency across the data that we're getting from everybody. We store those records in a database, we index records, and we publish them through our API. So next slide. So the primary activities, the things we're really doing as part of that process, that step of creating the new DPLA map records, that's where the meat of the process really is. And there's really 3 primary activities to that as we've defined them. So the first is mapping, and that's just translating or moving data values from one metadata schema in the original record to a metadata schema in the new record. So take the DC title from the original and put it in the title record of the map record, same thing with creator, contributor, etc. The second activity is what we've called normalizing, and this is just kind of slightly tweaking the format of the values so that they're consistent. So this involves things like removing brackets around titles, because not everybody use brackets around their titles. So the way to kind of normalize the common denominator would be to take the brackets out of everybody's titles, or remove ending periods, or remove white space, HTML, and things like that. The final activity we call enrichment, and that's where we actually add or enhance the records with new data based on what's actually there in the original record. So, sorry, next slide. So our initial ingest system, we've always been kind of bad with names. So our initial ingest system was created between 2012 and 2013. It was created by contract staff. It was intended as a very lightweight proof of concept, and it was specifically designed to handle the specific data of the 16 initial providers. So the way that happened was that there was a separate profile written for each provider that really intermingled these ideas of mapping, normalization, and enrichment, and dealt with each provider individually. It used a stack that included Python, CouchDB, and Elasticsearch, and we quickly kind of came to a point where those, especially last 2, were based on outdated versions of those applications. And it was based on the 3.1 iteration of the metadata application profile. So next slide. So that initial kind of that'll do for now structure was put together quickly to accommodate the initial partners, which are the states that are in the very light blue, and some number of service providers or individual institutions. So as we added partners over the intervening year, we kind of ad hoc added on new providers for each, or new profiles for each provider that continued to kind of intermingle these concepts. And what we ended up with, if you go to the next slide, is kind of a Winchester house of code. If you're familiar with the Winchester house, it's a house in California that's kind of amazing. The owners of the house have constantly added and remodeled and revised it into this sprawling maze of a house for interesting reasons. You can look it up if you want. But basically the idea is it was just added to again and again in ways that were redundant, that didn't make any sense, or that led to nowhere. So in the next slide, by the time we got to 2015, the code was difficult to parse and understand, particularly for non-developers. There was a lot of custom code for providers since those mapping, normalization, and enrichment were intermingled, kind of like the old Reese's commercial. You got your mapping in my enrichment and your enrichment in my mapping. It didn't enforce any data validation, so we didn't even comply with our own application profile in a lot of records, because there were just like kind of slight different ways of doing things that ended up in a bunch of different records. And we had no useful logging of errors to be able to troubleshoot any of those problems. And we didn't really have the opportunity to put a lot of time into QA or reporting because we were working so hard to just kind of keep this structure together. So with the next slide, we started work on what we called Ingest 2. The only one we named was named Hadron. And Cricri was the universal application, and Hadron was our local, I believe. It was developed between 2015 and 2016, and it was designed specifically to use linked data platform. So we'd be storing records in a native triple store format rather than flat individual records. Everything was modeled as RDF, and it was all based on using a lot of URIs and linked data, which is of course a good thing. Kind of philosophically, this was our first attempt to really separate out the mapping from the enrichment into different kind of reusable modular design, which is a very good thing. So in general, it was more modular and extensible. However, we found that linked data platform at that point really didn't scale well. It didn't scale to our needs. So we wanted to take some of the ideas of what we've been trying to do here and find a better way to do this activity. So next slide. So we are now working on Ingest 3, and we would welcome suggestions of clever names. So I characterize this as kind of, we're standing on the shoulders of the work that we previously did. We're basing this on technologies created for big data, particularly Apache Spark and the language Scala. We're creating something that's more modular. So the time we spent in intellectually working through the various mappings and normalizations for Hadron has informed the design of this new system. So that work wasn't wasted. It was work that we needed to do intellectually to kind of figure out those lines. But it is based on a larger pool of data. We have more than 40 hubs now who've provided content to us. So we have a lot more data to determine what types of enrichments work, what typical patterns exist in metadata, and how to handle them. And finally, we are benefiting from simultaneous updates to other parts of the overall picture, some of which Michael is going to talk about next. Updating things like our API, our Elasticsearch that we use, mean that we can more easily see actually the end results of updates to our data model in real time. So next slide. So with our new system, we're doing the same activities as the previous one, but we've improved each portion of the workflow, from how we plan and carry out the mapping, the normalization and enrichment, through the code creation and maintenance, and in the QA and reporting we can do. So you can go ahead to the next slide. You can see we check all those off. I'll go through each of these one by one. So mapping still works much like it always has, moving data from one property to another. In our revised crosswalk spreadsheet, which those of you who've worked with us on aggregation before have seen a spreadsheet very similar to this, we're separating out the mapping, which is in the column that's highlighted here, from, on the next slide, you'll see the normalizations and enrichments that should be applied to every field and every record, such as reducing white space, stripping HTML, and the specific normalization for individual fields that also would occur to every record. So for every alternative title, we want to clean up the punctuation and strip the brackets. For every contributor, we want to strip out an ending period. That's a smart enrichment. So if it's a word like junior at the end with a period, it won't do that. But then we also have, in the next slide, another column where we can call out specific enrichments or normalizations that a specific provider needs. So for example, the Ohio Digital Network uses semicolons to indicate multiple contributors in a single property. So we know that we can invoke a split it delimiter specifically for this provider on that property, and as part of the process. So in this way, we've kind of, split out the peanut butter from the chocolate to extend the metaphor. We've from the very first step started to divide out what we're doing in each of these different processes. In the next slide, you'll see an example of some of the new code that we've written. So this is much more human readable than the previous Python code was. We have some very straightforward mappings here. If you can kind of follow along. If you can't, don't worry about it. But you can see in the mapping here, we're creating the creator field from the creator property in the original, the date from the date. In this case, we're mapping records that are very close. We can also see the specific enrichments and delimiters and filters that are clearly indicated as well. So underneath in the first, on the third line, we can see we've invoked a split it delimiter on semicolon there. So for this one, we know we need to split these up at a semicolon. At the bottom, we can see a couple of filter lists that we've created to filter out terms that we don't want to appear in the format field. We're filtering out terms for digital objects here, like JPEG and PDF, and we have a list of those that we've invoked here. On the next slide, you'll see that the universal enrichments aren't created in the mapping property by property, but instead are assigned to classes of property and are only need to be created one time. So by declaring that the creator is an agent in the mapping, it will then inherit all of the normalizations that are universally applied to all agents. So you can see how the structure of the spreadsheet where we're creating the mapping is kind of mirroring the structure of the code, which is making it a lot easier to keep these things in sync and for the communication and understanding to be clearer as we go through the process. In the next slide, we're also working on improving our quality control and our reporting and logging abilities. QA is and remains very resource intensive. It relies on human review, and we have a limited number of humans. But we have a lot more ability now to generate reports and logs of activity, which increase our quality control overall. So we can do validation of records. We can check if they have required properties, and if they don't, send a warning or reject the record. We can keep logs of when records fail to map and why, and we can compare the values before and after an enrichment to see if the enrichment worked properly. So on the next slide, kind of as a summary, it may beg the question, kind of what's the big deal? Is this just about DPLA being able to do their work easier, or does this have an impact on the larger community, the DPLA community? Well, I think it isn't a shrug. I think it's a reason to be excited. Most of these things that are listed here have to do with validation and helping to keep the data more uniform than previously. And that means that we're able to do more exciting stuff. So we're able to do better large-scale analyses that are of interest to the community. We're able to pinpoint where remediation and intervention is needed and be able to communicate that back to hubs. We're able to pinpoint and resolve problems better. And hopefully, we'll be able to do more data enhancement in the future as well. We've started to talk about subject and format enhancement. We've talked about reconciliation with authorities. and improving the accuracy of existing data. And hopefully, we'll be able to use more of the features that were built into subsequent versions of the application profile, but haven't been utilized yet because we haven't been able to get all of these systems between the ingest system and the API and other infrastructure systems kind of in sync and up to date. So lastly, I just wanted to give you a kind of status of where we are. We have had 3 new providers who have completed their ingest through Ingest 3, and we have 4 existing providers who've already been migrated, and that is in basically the last few months. We have 4 new and existing providers that are currently in progress. And every time we finish one, the next one's a little bit easier because we work out something related to mapping a metadata language for the first time or harvesting from a source for the first time. So this is really starting to have a snowball effect, and I think that things are starting to move along at a much faster pace. Those who are more, I put in quotation marks, difficult to ingest in Ingest 1 are getting migrated first among our members because we have had more problems getting them through the Ingest 1 system. And that has nothing to do with whether or not the data that the providers are giving us is good or not good. It just is for various kinds of reasons related to Ingest 1 and its kind of crazy infrastructure. Some things cause us more problems than others. So some of those providers are heading to the top of the list. So if you are towards the bottom of the list, it means that we've had a relatively easy time working with you in Ingest 1. And so our hope is that there will be a big kind of break in service for you. As we're working on migrating our providers into this new system, we're also working on refactoring and working on some of those enrichments and quality control reports that I talked about. So we've already refactored some of the format and type enrichments, which I kind of alluded to in those filters that I mentioned previously. There's a number of those that we've developed. We're currently working on refactoring date enrichments, and we're getting ready to work on spatial enrichments. Once we have those completed and in place, we will be putting out guidelines for partners so that they understand exactly what the enrichments do and what kinds of values work really well with them and what ones are more problematic. And we'll be putting out full documentation on those, but we are kind of working on them as we work through the data. And we're also implementing new reporting and error logging workflow. So those of you who've already been migrated, we should, by the next time you're ingested, have even better reports and error logging for you. And for those of you who haven't yet, that is what you have to look forward to. So that's the end of my ingest update, and I'm going to hand it back over to Michael for some other things related to infrastructure.
Okay, thanks, Gretchen. And I hope I nailed the timing on that emoji transition.
Yes, that one was good.
All right, good. Yeah, we didn't really rehearse that. That was all live. Okay, so I'm going to take a second to talk about some of the changes we've been making in our data architecture, which speaking more about the flow of data and less about what's in it, which was more what Gretchen was talking about. So we've switched over to a system where we're keeping all our data in Amazon S3. It's now our system of record. And for those of you unfamiliar with Amazon S3, it stands for Simple Storage Service. It's basically a sort of a file system that is really redundant and really durable. Previously, we had our data stored in a number of different places, but arguably you could say that our search index was our system of record because we have more than one system in flight, and that's kind of a bad place to be. Search indexes are great, but they're not really sort of durable data stores in the same way that some other things can be. In particular, Amazon S3 is a great place to be if you are working with a big whack of data and you're not like using individual files. And so in our case, we, as you can see here, are storing each provider under its own folder. And basically, the data architecture now is based on something called Lambda architecture from the book Big Data Principles and Best Practices of Scalable Real-Time Data Systems. Oh, that was a breath. Which is a Manning Publications book. Essentially, the idea is that data is written to timestamp directories, in our case, Amazon S3, and we never overwrite it. which really eliminates a lot of the potential for operator error, because if we build a new file that doesn't work, for whatever reason, we can just delete it and the old one's there and we'll pick that up the next time we index. So that provides a really easy rollback mechanism and really easy upgrades, because essentially from our point of view, S3 is sort of like an infinitely scalable resource. We don't have to worry about, say, 2 people reading it from once, or suddenly we want a really big search cluster and we're going to have a lot of different workers taking stuff from the file system and bringing it to the search cluster. S3 is infinite from our perspective, or any scale that we're going to be at. So that brings us to mass indexing. The idea here is that we've rolled out a new search cluster, which is now Elasticsearch 6, which we upgraded from Elasticsearch 090, which is pretty much the earliest version of Elasticsearch that is still available and really is antiquated in many ways. And so we immediately realized some really big benefits from this. For one, based on some extensive load testing, we were able to decide to bring down the number of hosts serving the search index while still serving the same amount of traffic, which means we realized a pretty good cost savings. It's about 30% or so. Our search cluster is actually our most expensive Amazon hosting cost, so that's pretty significant for us. Likewise, the load on our hosting infrastructure generally has gone way down since the new search cluster is a lot quicker at turning around responses. So those other boxes in our systems don't have to wait for responses as long, and so they can serve more traffic. So along with that upgrade to Elasticsearch, we were able to make use of some libraries that work directly with newer versions of Elasticsearch to do what we're calling mass indexing. Basically, the idea is that we are able to rebuild our entire search index in less than an hour. So, starting from a collection with 0 records in it to 20-something million takes less than an hour. And basically, we just push a button and the data gets deployed up there. Now, there's a step in between making it live, building it and making it live that involves human intervention, because we want to have that touch point there to make sure that we're really doing the right thing. But the step to make it live is another button that you just press and boom, you have a new search index. So generally speaking, our workflow now is we ingest people, their data ends up in a new version in Amazon S3, and then whenever we feel like it, we can press a button and make that go live. So, for whatever business reasons, like someone was waiting on this record, or we want to wait a little while to let someone get in, the choice is ours. So this way of doing our search index, rather than incrementally updating an existing standing index over and over, is really great for schema migrations and disaster recovery. It's really a boon for our flexibility, because if we need to add more fields to the index, or upgrade software, or change how existing fields are analyzed in the search index, we can do so really quickly. We can even set the 2 versions side by side and test how the changes would affect production. So we've recently done that with some updates that we got from NARA. They have sent us a data set that's something around 10 million records, and we were able to set up another search index and another version of our app and see what that looked like in terms of relevancy and competing with our other providers in our index. And it turns out that everything is going pretty well. So we're going to probably make that data live pretty soon. We wouldn't really be able to do that in a land where all our data was being incrementally updated and always stayed in the same index. So this is a lot more flexible for us. Alongside our search index, we are now working on a new API. So it's basically a re-implementation of the existing API that we have. And the reason why we're doing this is that we can focus on being performant and maintainable, and with an eye to being able to add some new features onto it later. What we have doesn't really get us that. It's sort of incrementally updated, and it's a little overcomplicated, I would say, for what the job of our API is, which is to convert like API calls into search queries and send the data back. But when we're done with this, it should be compatible with the existing API implementation. So we don't expect to be breaking anything for anybody. Another reason why we might want to do that kind of thing is to work on some potential new search features, because now we have a new search index or a new search software, which gives us some more functionality. So here's some features we'd like to be able to add to the site once we cut over to the new API. First off is autocomplete, which is the ability to predict what the user might be searching for based on what they've already typed and being able to suggest some terms or completions to what they've been typing. We have prototyped that, but we haven't really gotten into implementing that, but it's something I would imagine we're going to be building into the new API because it's something that comes more or less out of the box with a new Elasticsearch in a number of different ways. Another thing is spelling correction, which would let us suggest some alternatives if a user ended up with fewer 0 results to their search. So instead of that being a cliff that you are potentially running into when you can't find any food in your search index, which would be the darkest day at DPLA, I'd have to say. We can be suggesting some things that people might also want to search for that are similar to what they searched for and get them back to content. Finally, more like this is something that uses the power of the search index similarity engine to use a given item as a query to discover other items like it. So we'd like to be able to add that to an item page to drive more traffic around the site rather than the item page being a stopping point or another cliff for users to fall off. So, you know, you landed on an item, you thought it was good, but maybe there's some other things like that that didn't show up in your search results. We'd like to be able to kind of suggest that and say the right-hand column and give people more things to click on. So that is it for our slides today, and I think we're going to open it up to questions.
Yeah, it looks like that I added that question slide, but it looks like it didn't update the version you had.
I'm sorry, I was in presentation mode, maybe that's why.
And then I accidentally just unplugged my laptop and dropped from the call. So I lost the log of questions that we had, but there were 2 at the bottom. So Samantha and Michael, if you open your Q&A, they should be there.
I'm not actually sure if I can see that because I'm sharing screen right now.
Okay.
I can help.
Okay.
Great.
Okay, so one question that we got, does DPLA local use the same code base as DPLA/Pro with feature flags?
Yes, it does. So yeah, that's really literally the same components, just configured slightly differently. It is the same code base. And actually, if I roll back to a previous slide, one of the slides that I was showing Elastic Beanstalking, you'll see that there is a local demo sitting there in the same Elastic Beanstalk environment as our pro site and our production product site and our staging stuff. It's all the same thing with just different flags flipped.
Great. Okay, next question is development documentation for Ingest 3 tools mainly going into the Confluence site, GitHub, or DPLA Pro? And are you developing them mainly for in-house use at DPLA or with an eye towards making them usable by hubs at all?
Sure. So I'd say right now most of the documentation exists in Confluence in our wiki. I think this is sort of one of those things where we are kind of in production and building something on the fly, and so we have kind of been changing things up as we run into problems with our plans. And so it's sort of like one of those agile software projects where the situation on the ground is changing rapidly, but I think overall that we can do more to help people understand the software we have been developing and document it a little bit better so people can understand why we've made some of the choices we've made, and if they want to kick the tires or run it themselves, that's possible too. There is an upcoming webinar about Combine, which is an effort to take some of the software that we've written for Ingestion 3 and reuse it for something that works at a hub level or more of a local aggregation level. Because I think really some of the design considerations that are built into Ingestion 3 are really meant for kind of working at the record count and the kinds of data diversity that we see at DPLA rather than what a hub might want, which might be more limited and also have other workflow considerations that we aren't taking into account at all. So I think that that's a pretty promising route for like technology reuse without literally making this one project kind of like have a too many cooks or maybe too complicated of a list of requirements thing going on. I think, you know, Combine has a web UI. It has different ideas baked into the workflow there, and I think it's probably the better way forward, assuming that you kind of have the same problems that it solves versus ingestion 3, which solves kind of, you know, DPLA's problems. So I can't say that no one would find ingestion 3 useful or no one should look at it, because that's definitely not true. I mean, that's how Combine came about. But at the same time, I think Combine might be, for most people working at hubs or in smaller aggregations, another thing to look at and another thing to focus on.
It looks like we've had a few more questions come in. So the mapping code that was showed during the ingest 3 update, I believe, is the object of the question is that mapping in Scala. I believe it is. That is,
yeah, it is.
Scala mapping. Those are in our GitHub repository in the ingest 3 project, if you're interested in looking at them. Another question was about the completeness measure in the analytics dashboard. Is it only based on the presence or absence of field, or does it take into account multiple occurrences for the same field? I believe that it is based on presence or absence. So if a subject is present, then it is counted as a record with a subject. So the measure is of records that have the fields, not the number of fields present in the overall text. It's a very, very simple measure at this point. It was kind of implemented as just let's put something out there to get started, and then let's have some more conversations about what would be useful metrics. And we haven't gotten kind of to that part 2 of that question yet. So it is pretty simple at this point. There's another question in the chat about the DPLA local customization. Is that available for contributing institutions, or is it only at the hub level? So it's certainly being piloted right now at the hub level, and as part of membership. If the hub joins the DPLA membership, it would be something that would be available. We haven't really worked out all of the uses or ways we might work with the idea. So certainly something could evolve over time, but that is definitely the current intended use is for the hub level. Would you want to add anything to that, Michael?
No, I mean, I guess it's something, you know, we just started working on. We've built something and we're talking to a really limited group of users. And as we roll it out, and if there's potential for other projects, we'd be interested in talking with people. Does that makes?
Mm-hmm.
Yeah.
Okay, so we have another question about, okay, some of our partners have been complaining that the main search feature doesn't seem to index search subject fields, the one can filter by subject. Is an advanced search feature coming, or will the new index features change this behavior? We actually have realized recently that we've made some tweaks to this recently because we realized a couple of issues that were coming up with some new indexing. So we are working through some of those issues, and you may have stumbled on one of those because it certainly should be searching the subject fields.
Yeah, I think that's definitely something to circle back on and check. And if we're not doing what you think we should be doing, we'd be interested in hearing from you. So let us know. But we did just address a problem with that. That was, I think, post new search index software launch. And I think the release went out like a week or 2 ago.
Right. So, and that certainly isn't an intended effect. We haven't ever discussed having an advanced search feature. Hopefully, correcting that index issue kind of means that we don't need it. There's a question about current documentation on DPLA local. Do we have any documentation? The project is in GitHub.
Yeah, I don't think we've kind of really wrote up like any sort of white paper on that or anything like that, because it is a very, very new product and hasn't gone in production for anyone yet, but we are nearing that point. So, you know, we'd be interested in hearing your inquiries or what you're looking for to find out, but we haven't, you know, we're sort of like iterating towards an MVP for a specific small group of people, and then we're going to grow from there. So, we do intend to have that kind of information later, but right now the project's just sort of getting started.
There's another question about DPLA local, about whether or not there are any other features besides the local search that are planned. We have started to talk about in future kinds of iterations implementing other parts of the current DPLA site, like some kind of infrastructure for creating exhibits or primary source sets or topic browses. We're working with the same group to kind of work through those issues and decide what would be useful and what would be possible. You can also expand the search from local out to the full DPLA. So in that way, your users can start with a local search, but if they're not finding what they're interested in, or they want to expand their search, there are options to expand that out to the full DPLA, which I'm not sure if we showed a screenshot of that or not. Those are the main ones we're talking about now. Any other questions? While we have a short lull, I'll just mention that on this slide you'll see information about our upcoming webinars. On September 22nd, we will have guests from the Foundation Center talking to us about their Visualizing Funding for Libraries data tool, which can help you kind of in your efforts to look for grant and other support for projects. In December, we'll be talking with some of our partners at the Michigan Service Hub about Combine, as Michael mentioned previously, a tool that will help hubs with aggregation and data aggregation and sharing data with DPLA. I'm not seeing any other questions at this point. I'll say that if you have any other follow-ups or any other questions about these things or any other things you'd like to ask us or share with us, please don't hesitate to email myself, at least, Gretchen at dp.la. We'd be happy to hear your thoughts on things or help you out with any issues. I want to thank you all for being here today. It's been great to see so many people interested in what we're doing. With that, I think we'll just say thank you again and have a great day, everyone.
Thanks, everybody.